This 3-mark question involves working with vectors, combining two of them, and then looking at the size or the magnitude of the line that joins two of the points involved with the vectors. So let's do a sketch first of all of the two vectors. We have vector AB. AB goes 6, -9. You can see that with the column vector just here. So that is 6 to the right and 9 down. Remember, with a column vector, the top number is the way you move right or left, and the bottom number is the way you move up or down. Positive goes to the right and up, and negative goes left and down. So we have on this first one here, A, B. If I put a little point A here, I'm going to go 6 to the right. So do a little sketch. Let's say it's about 6. Then I go 9 down, so down to about here, and that would be my point B. And so this vector is represented with this line and the arrow going here. So that's visualizing what AB is. Now let's do CB. I'll put a point C just here. And CB is 1, 3. So I go 1 to the right. And then I go 3 up. Try and use a similar sort of scale for my other sketch. And that's going to be B. And it's C to B. So it's going up like this. Now I need to combine the two. And you can look at this visually and go, okay, well that can actually land on here like this. So that's really what I've got in my question here, the two vectors. A goes to B, C goes to B. They're both going towards B. And I want the vector of A to C. That's the one represented here. So I'm going to do that in blue. So I'm going to draw a line from A to C in the direction A to C there. And let's work out the size of this vector. First of all, I need to go across. Well, if you can see here, I would have to go across here 5 before I could go down. So that would be 5. And if I go down, I've gone -9 and then another -3. So that's -12. So A to C is going to be 5 minus 12. And I think a little sketch like this for this sort of question is quite a useful tool. That's the vector A to C, but that's not what the question asked for. It asked for the magnitude. Magnitude is just the length or the size of that vector. So looking at this, what I actually have is I have a right angled triangle whereby I have this length of 6, this length of -12, and then I'm trying to find the hypotenuse. So what I would do for my workings is I would say that the magnitude of A to C is equal to the square root of 5 squared plus -12 squared. The fact I refer to it as a -12 length is just showing the direction going down. Once I square it, it makes absolutely no difference, because what you've got then is I've got 25 plus 144, which hopefully you've already spotted that this is a Pythagorean triple. That's going to go to 169, and when you square root that, you get the answer of 13. There's no units here, so 13 would be the answer for the magnitude of vector AC.